Hello everyone. After learning the first part of our this fifth topic, straight line, locus and shift of origin, we will move towards the second part of this straight line. In this second part, we will learn 7 concepts. First concept is simplest locus, line as a simplest locus. In second part, we will discuss about the intercepts made by line on x-axis and y-axis. After that, we will learn the important property or concept, that is inclination of a line. Inclination of a line. Then the most important formula or concept of this topic, that is the slope of a line. Slope of line. Then the fifth concept is about parallel lines. We will find the relation between slopes for parallel lines. Next will be about perpendicular lines, the relation between the slopes of two perpendicular lines, and the last important article is angle between two intersecting lines. So these are the 7 points on which we will discuss now. Let us see first one, that is simplest locus, line as a simplest locus. If you draw any line, then on this line there are infinitely many points. If you take points A, B, C, D, E, which are points on this line L, then we know the formula to find slope of line. If you find the slope using these two formulas, these 2 points, then slope of this line by taking A and B as 2 points, and the slope of this segment CD or slope of DE, all these slopes are the slope of single line. So slope of any 2 points on line is always constant, and that is the condition. So this line is a locus, and in the plane, line is the simplest locus. Let us move towards second point, that is intercepts of a line. Let us take system, x-axis and y-axis origin, which is the point of intersection of 2 axes. If you draw line which is inclined to this x-axis, then this line cuts x-axis at certain point, suppose A, having coordinates A0, and the line cuts y-axis at point, suppose B, having coordinates 0B, then this will be distance A, and this will be distance B from origin. So the distance of this point of intersection of line with x-axis from the origin is called as the x-intercept. And this B is nothing but y-intercept. So these are the 2 intercepts made by this line on x and y axis. Then can we think that whether this intercept is 0? Yes, this intercept may be equal to 0. It may be x-intercept or y-intercept. It may be 0. How? Because if line passes through origin, then there is the point of intersection of line and x-axis, which is origin. So distance of origin from origin is 0. So if line passes through origin, suppose line is like this, then the intercept made by this line L2, the intercept made by this line L2 with x-axis is 0 and with also y-axis 0. Whenever line makes intercept with x-axis 0, means it passes through origin, then its y-intercept is also 0. But sometimes a line which are parallel to axis, let us see line which is parallel to axis. If suppose line is parallel to y-axis, then it has only x-intercept. This, if line is parallel to y-axis, it has x-intercept. If second line is like here, then it has this much x-intercept. If line is here parallel to y-axis, then this will be its x-intercept. Intercept may be positive, may be negative. As an intercept it is negative, but as a length it is always positive. So if this line cuts x-axis at this point having intercept 3, this as a distance it is 3, but this point is minus 3, 0. So intercept, we call intercept as minus 3. So this sign positive negative indicates whether line cuts x-axis at towards positive side or towards negative side. So intercept may be positive, may be negative, may be 0. If line is parallel to x-axis like this, then it has intercept this much, which is positive intercept. If line is parallel to x-axis and below origin, then it has intercept this much. This is the intercept made by this line on y-axis. So this is y-intercept, no any x-intercept. So line makes x and y-intercept with x-axis and y-axis. Let us move towards third point, that is inclination of a line. Inclination of a line. Let us consider system once again. This is x-axis, y-axis, origin. If you draw certain line in this plane, then it may be x-axis parallel to x-axis, may be y-axis parallel to y-axis, or it is non-parallel to x and y-axis. So sometimes that line may be like this. Suppose, for instance, I am taking this line L. If line is like this, then it makes x-intercept here and y-intercept here. At this point, here is formation of angle. Let us take some letters here. Suppose this is x point, this is A, this is B. Then here is the formation of angle. This is one arm of angle and this is another arm of angle. So that if you measure this angle in anti-clockwise direction, then this will be positive angle. So this positive angle, that is angle XAB. Angle XAB is positive angle. If we consider this angle, then this is also positive. But here for this angle, this arm AX, this AX is on x-axis and it is towards positive x-axis. So this is its initial arm which is on x-axis. But if you consider this angle, then this initial arm does not lie on x-axis. If we take this angle having initial arm along x-axis and final arm along this line, suppose along AC, then this will be negative angle because direction is in clockwise direction. So if you consider this angle, then this is again negative angle. If you take this angle in this way, then in this way this is our initial arm and this is final arm. So initial arm is not x-axis. So if you consider any angles here, because we have different angles at this stage, but out of these all angles, this is the only angle which is in anti-clockwise direction, means positive angle, which is in anti-clockwise direction, and that is positive angle, and whose initial arm is along x-axis. So this is the angle, we call this angle as inclination of a line. Remaining are angles made by line with x-axis or y-axis, but this is the unique angle which is made by line with positive direction of x-axis, or it is the angle between line and positive direction of x-axis, and that angle is also positive. So this positive angle which is in anti-clockwise direction and whose initial arm is along x-axis, the main condition is that and initial arm is along positive x-axis. So these are the three conditions, that angle should be anti-clockwise, means it is positive, and whose initial arm is along x-axis. Then that angle is said to be inclination of a line. So this inclination is nothing but angle. So we can denote that inclination of line by symbol theta. That is the symbol of angle. So inclination of angle is theta. Let us come towards fourth point, that is slope of line. As theta is the inclination of angle, what is theta? Theta is obviously a real number. This theta is a real number. Now we will move towards this slope of a line. Slope of a line, for this slope we will consider a formula tan theta. Means in words we can say that the tangent ratio of inclination of a line L is called as slope of a line, and it is denoted by letter M. Slope is denoted by letter M. So tan theta is nothing but slope. This tan theta means tangent ratio of inclination of angle. This inclination of angle, this angle may be, the condition for this angle theta is between, it may be equal to 0 but less than 180 degree, because sometimes line may be parallel to x-axis. If suppose line is like this, then its angle made by this line with x-axis will be of 0 degree. Sometimes this line may be like this, making angle of 30 degree. Sometimes a line may make angle with x-axis as 45 degree. Then in this way 90, then again 120, 135, 180. But suppose if you consider that line is making angle 180, it is equivalent to 0. So the limits for inclination are 0 and 180. So this theta is less than 180 and greater than or equal to 0 degree. And from that theta we can find the slope of line M. Let us see the formula to find slope of line, which we have done in 10th class. Once again we will revise it. This theta is the inclination of this line, x-axis, and this L, line L. If you take any point A here, then A is nothing but x1, y1. Let us take another point B, having coordinates x2, y. We want to find tan theta, value of tangent ratio of theta. We know the formula for tan theta in trigonometry, that is, if theta is the angle of right angle, the acute angle of right angle triangle, then tan theta is nothing but the length of opposite side upon length of adjacent side. Let us form here triangle so that we get theta is one of its acute angle. If you draw perpendicular from point A, then this side, suppose if you draw perpendicular from O, A on x-axis, then we get triangle ACD, which is right angle triangle, and theta is acute angle. So in this tan theta, we get opposite side as AD and adjacent side as CD. AD upon CD. If you draw perpendicular side, perpendicular from B on x-axis, then also we get triangle BCE, in which for this angle, acute angle theta, B is opposite side and C is adjacent side. So it is also equal to BE upon CE. BE upon CE. For simplicity, again we will draw perpendicular from A on this line BE. So if you draw perpendicular from A on BE, then these two lines are parallel lines. For instance, I will extend this line. Then these are two parallel lines and this is their transversal. So this angle and also these two are parallel. So this angle theta is nothing but this. These two theta angles are congruent. This angle BAF and angle BCE are congruent angle, as this triangle and this large triangle both are similar triangles. So these are corresponding angles. Now in this triangle ABF, again we can write tan theta is equal to opposite side is BF upon adjacent side AF. So for tan theta, in this figure we have three right angle triangles, so we get three equal ratios here. From using any one ratio we can find tan theta here. For this triangle, tan theta is this much is y1, this much is x1. Suppose not actual y1, this much is x1 and this much is y1. So this x1 is this. So if you find this CD, then we can take ratio and we can find tan theta. We will see in this triangle. Whatever the values of x1, y1 and x2, y2, this one is y2 and this one is y1, this is also y1. So this BF becomes y2 minus y1. Do you got this point? This BF is nothing but y2 minus y1. Here also, what is this? This is nothing but x1, x2, that is the distance of point B from y-axis, that is x2. So this distance AF is nothing but DE and it is equal to OE minus OD. So x2 minus x1. So this distance is x2 minus x1. So let us put the values of BF and AF. BF is y2 minus y1 and AF is nothing but x2 minus x1. So we get the formula for tan theta. If you know 2 points on line x1, y1 and x2, y2, then using the coordinates of 2 points on the line, we can find tangent ratio of inclination of that line by using this formula. And this tangent ratio of inclination of line is nothing but the slope of the line. So the formula for slope of line is y2 minus y1 upon x2 minus x1 under condition that this x2 minus x1 should not be 0. It means x2 and x1 should be different. When it is possible, if line is parallel to y-axis, then at this stage here, if x1 and y1 are the coordinates of point A, then the x coordinate of B is also x1. Y2 will be different. So when line is parallel to y-axis, then we can't use this formula. So this tan theta is not possible only if line is parallel to y-axis. So for this formula, the condition, remember condition that x2 and x1 should be different. So this is the formula we will remember that is slope n is equal to tan theta and it is equal to y2 minus y1 upon x2 minus x1, where x1 and x2 should be different, means the line should be non-parallel with y-axis. That line should not be vertical. Now let us come towards this fifth point, parallel lines. If we have two parallel lines, then once again consider figure. If suppose one line is like this and second line is like this, these two lines are said to be parallel. We can define here the parallel lines if their inclinations θ1 and θ2. If L1 and L2 two lines are parallel, then they are said to be parallel if their inclinations θ1 and θ2 are equal. So parallel lines implies θ1 equal to θ2. If θ1 and θ2 are equal, then can we take their tangent ratios? Yes, tan θ1 equal to tan θ2. Then their tangent ratios are also equal. So whenever two lines are parallel, the inclinations are equal, their slopes m1 and m2 are also equal. So remember this, if two lines are parallel, their inclinations are same, their tangent ratios of inclinations are equal, it means their slopes are equal. So that is about parallel lines. Let us move towards perpendicular lines. For perpendicular lines, let us see the important result about perpendicular lines. If two lines are like this, if suppose this line L1 and line L2 are perpendicular to each other, then L1 and L2 are perpendicular to each other, then angle between them will be obviously pi by 2. If inclination of first line is alpha and beta is the inclination of second line, there may be lines. Let us see different lines once again. In this case, if lines are like this is line having inclination alpha and a perpendicular line to this line having inclination beta. These two lines are perpendicular, so this angle is again pi. So this may happens that the inclinations of L1 and L2 may get interchanged. Means in this case, if we see here the triangle, then here triangle A, B, C. Suppose once again ABC. So for triangle ABC, this alpha is the exterior angle, and for this triangle ABC, beta is the exterior angle. Angle between two lines is same because they are perpendicular, that is 90. but the inclinations, if you interchange this alpha here and beta here, then we get these two different situations. In this situation, by exterior angle theorem, which we have learned in 10th class, we can write that this alpha is equal to this plus this, that is 90 or pi by 2 plus beta. In this case, we can write beta is equal to 90 plus alpha. So, in both cases, from these two cases, we can write single general case as this implies alpha minus beta equal to 90. So, alpha minus beta is equal to 90 degree. Here, alpha minus beta is equal to minus 90. Alpha minus beta is equal to minus 90 degree. So, alpha minus beta is equal to either plus or minus 90 degree. From these two results, we can conclude that alpha minus beta is either plus 90 or minus 90. Okay, let us move towards that result. So, from these two, we get that alpha minus beta is equal to plus or minus 90. So, as this difference is equal to plus or minus 90 degree, if you take the cosine ratio of this, then cos of alpha minus beta, that is equal to cos of plus or minus 90. Whether this angle is positive or negative, cosine ratio is always 0. So, cos of alpha minus beta is equal to 0. If we use this formula, we have not studied yet this formula, still we will use it. Cos of alpha minus beta is nothing but cos alpha cos beta minus plus sin alpha sin beta is equal to 0. Cos of alpha minus beta is cos alpha cos beta plus sin alpha sin beta is equal to 0. Whenever here is negative sign, here we get positive. Product of single cos alpha cos beta and sin alpha sin beta. Then from this we get sin alpha plus sin beta equal to, we can write sin alpha, keeping this sin alpha sin beta to the left side, we will take this to the right side, it becomes minus of cos alpha cos beta, taking this cos alpha cos beta to the left side, therefore we get sin alpha sin beta upon cos alpha cos beta, that is equal to minus 1. This sin alpha cos alpha, that is equal to tan alpha, and this sin beta upon cos beta is equal to tan beta, and it is equal to minus 1. But what is tan alpha? If alpha is the inclination of first line, then obviously from this formula tan alpha becomes slope of first line, that is m1. So we can write here, if two lines are perpendicular lines, then this tan alpha is nothing but m1 and tan beta is nothing but m2. The product of slopes of two lines is minus 1. So whenever lines are perpendicular, product of slopes is equal to minus 1. That is the most important result about perpendicular lines. So remember these results. We have done about parallel lines, implies m1 equal to m2, and about perpendicular lines, we learn that m1 into m2 is equal to minus 1. So these are three results which will be very much useful in our further study of straight line. First one, that is the slope of line, that is equal to tan theta equal to y2 minus y1 upon x2 minus x1. If lines are parallel lines, then their slopes are equal. and if lines are perpendicular, then the product of their slopes is -1. So remember these three important formulae. Now we will move towards our last point, that is the angle between two intersecting lines. We will solve some examples on each article in our next lecture. Now the last point remains, that is angle between two intersecting lines. This is our 7th point of this article, this lecture. Theorem related to this 7th point. If theta is the acute angle, this acute word is important here. If theta is the acute angle between any two intersecting lines, then tan theta means tangent ratio of angle between those two lines is equal to mod of any two intersecting lines having slopes with slopes m1 and m2, then tan theta is equal to m1 minus m2 upon 1 plus m1 m2. In commerce textbook, the proof of this theorem is not given. You can use directly this formula for finding angle between two lines. But in science textbook, the proof of this theorem is given. We will see the detailed proof for this theorem. Proof. What is given? M1 and M2 are the slopes of two intersecting lines that is given. Once again, we will first see the angle between two lines. What is meant by angle between two lines? Why here acute word is given. After that we will find the formula. Suppose two lines are given, then two lines may be parallel, may be non-parallel. So if two lines are parallel, there is no formation of angle. So if lines are parallel, we say that angle between them is 0. If lines are intersecting, then they may be perpendicular or non-perpendicular. So there are again two cases. One is perpendicular lines and non-perpendicular lines. So this, if lines are perpendicular, then no need to find the angle between two lines because lines are perpendicular, so angle will be 90. If suppose lines are non-perpendicular, lines means intersecting. So whenever two lines are intersecting, means they are not perpendicular to each other, then we can consider these two lines. So if you draw any two lines, then there is formation of these four angles. Out of these four, these two are congruent because they are vertically opposite. These two are congruent because they are also vertically opposite. So remains only two angles. Out of these two, if lines are not perpendicular, one will be acute angle, other will be obtuse angle. So which one is simple? This is small angle, this is large angle. So we will consider only acute angle between those two lines. If at the same time, if suppose lines are like this, then in this situation, the angle between these two lines will be this. Suppose theta is the angle between two lines. Then we will take theta here, not at the same position here. So theta is the acute angle between two lines. Now consider the system for these two lines. Here we will take the same system for these two lines. again consider the lines L1, L2, L1, L2. This line L1 has inclination alpha. This line L1 has inclination again alpha. For simplicity, I will change this line because here is formation of intersection. So I will draw that line here. This is acute angle theta. This is line L1, which makes inclination of alpha. Now this is line L2, so it has inclination, suppose beta. So in both situations I will take symbols as points of intersections as A, B, C. Here also A, B, C. Simultaneously we are considering two cases in which one angle theta is towards downside and one angle acute angle theta is towards right side. Because in this triangle ABC this theta is acute, but in this triangle ABC the same angle is obtuse. So if alpha and beta are the inclinations of these two lines, then again we get external angle here beta in the same situation. So we can write here, once again we get the similar equations. That beta is equal to alpha plus theta or theta plus alpha. Here we get beta is equal to, now internal angle here is pi by 2 pi minus theta, because total angle is 180, 180 means pi. So pi minus theta is our this internal angle of triangle ABC. This is external angle. So here beta is equal to alpha plus pi minus theta. Alpha or pi minus theta plus alpha. Anyway, in this situation again we get the difference of alpha and beta, that is, let us find theta from this. Theta is equal to beta minus alpha, and here theta is equal to, taking this theta to the right, we get pi plus alpha minus beta, plus alpha minus beta, or we can write this angle as pi minus of beta minus alpha, so that we get same beta minus alpha. So here we get theta is equal to beta minus alpha. In second situation we get theta is equal to pi minus beta minus alpha. What we want to find here? We want the formula for tan theta, and it is given in formula as m1 minus m2 upon 1 plus m1 m2. That we have to prove here. So let us take tangent ratio of these two. So here tan theta is equal to tan of beta minus alpha. Here tan theta is equal to tan of pi minus of beta minus alpha. Here is no any problem. Here is additional pi is there. So I will place here the figure. Once again, if required, I will draw the same figure again. Now, tan theta is equal to tan of beta minus alpha, and tan theta is equal to tan of pi minus beta minus alpha. So, by using formula for this, we get tan of pi minus means there is no change in trigonometric function. So, tan of beta minus alpha. Here, pi minus means angle is in second quadrant. In second quadrant, this tan is negative. So, we get here minus of tan of beta minus alpha. So in first case, if theta is the acute angle between two lines, so that beta is external angle, then we get tan theta is equal to tan beta minus alpha. If alpha is extra angle and this theta is obtuse angle, sorry, beta is extra angle and theta is obtuse angle, then in that case, if theta is obtuse angle, we get tan theta equal to minus tan beta minus alpha. If you want to combine these two situations, then we can write this as tan theta is equal to modulus of tan of beta minus alpha. So mod of this tan beta minus alpha, if you take the mod of these two, then it becomes positive only tan theta. So these two situations are written in this single equation. And now let us use the formula. So we know that the tan of A minus B, once again I will write here formula, tan of A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. So using that formula we can write here tan beta minus alpha is nothing but tan beta minus tan alpha whole divided by 1 plus tan beta into tan alpha. Instead of beta minus alpha, we can take alpha minus beta also. If we change the positions of alpha and beta, then we get here the relation as tan alpha minus tan beta upon 1 plus tan alpha into tan beta. We can interchange the positions of alpha and beta. But as alpha is the inclination of first line, so its tan alpha becomes slope, and the slope is given m1. Or if you consider this equation, then this will be m2 minus m1 upon 1 plus m2 into m1. Or we get the result as from this m1 minus m2 upon 1 plus m1 m2. So these are two similar formulas. You can take or you can start with m1 or m2. There will be no change in this tan theta, that is the angle between, this theta is the angle between two lines. So this is the tangent ratio of acute angle between two lines. And to find this, from this we can convert, or if you want to find only theta, then we can write this theta is equal to taking this tan to the right, that is tan inverse of m1 minus m2 upon 1 plus m1 m2. One condition once again arises here, that denominator is here, so in our mathematics this denominator should not be equal to 0. So this m1 1 plus m1 m2 should not be equal to 0, that is m1 m2 should not be equal to minus 1. But in our previous article we have learned that if m1 m2 is equal to minus 1, lines are perpendicular